Today we are going to discuss about the next topic, which is electric dipole. Okay. In this topic, we will study about the electric dipole moment, and some questions related to the electric dipole moment. And after then, electric field due to the dipole at axial line and electric field due to the dipole at the equatorial line. Are you clear? This is the topic of today's lectures. Okay. Let's understand what is the electric dipole. Remember that the configuration in such a way, or you can just, if you want to understand in the simple language, then you can see the magnet and the electric charge. Electric charge always a monopole body like this. In electric charge, either it is positive or negative. Are you clear or not? Electric charge either be positive or negative. But if you take a magnet, then you have already know in a magnet there are two poles are found, north and south pole. Are you clear or not? So we can say electric charges are monopole, okay, whereas the magnet is a dipole body. Are you clear? Dipole in the sense in which two poles are found, that are said to be the dipole. Clear? Hello?
Yes, sir.
Yeah. All of you understanding? Mansi, Nida?
Yes, sir.
Yeah. Okay. Dipole in the sense two poles only. Okay. Now, let's try to understand its definition first. Dipole in the sense two poles. Okay. Electric dipole can be made by assembling two equal and opposite charges, okay, separating at a very small distance. So we can write here assembling of two equal and opposite charge separated by a small distance. You can say 2L. Okay, small distance in the sense, no need to write here, don't worry. By a small distance constitutes electric dipole. Constitute electric dipole. Are you clear? Just like this, we are taking two charges. The one of them is positive and the another is negative. Remember that the main condition of the electric dipole is these are always be two equal and should be opposite also. Okay, this is the main condition, and the third main condition is these charges are separated at very small separation also. When you try to join these two charges like this, then what will happen? This is your plus Q charge and this is your minus Q charge. Okay, separation between them, we are taking 2L. Okay, these 2L is very small distance. Okay, and magnitude of both charges will be same, as well as nature should be opposite. Then the constituent, then they constitute dipole. Are you clear? All of you are understanding or not?
Yes, sir.
Yeah. Now, some Examples of monopole and dipoles are like, what are the monopoles? Monopoles like electron, proton, and so on. These are the monopole bodies. Monopole bodies in the sense, these are the bodies in which single poles are exist. Are you clear? Either it is positive or negative. Okay. Whereas in dipole in the sense two poles, just like HCl. HCl you have already know, H and Cl. H is positive and Cl is negative. You can look at here, the amount of positive charge at H is 1. Okay. And chlorine is also 1, but opposite in nature. The another example like NaCl. NaCl is your salt, which is also known as the sodium chloride. In this, Na is plus and chlorine is minus. These are also formed dipoles. The another third example of dipole is magnet. Magnet have two poles, north and south poles. Are you clear or not? So please note it down. Note it down, please. Akshay, have you any issue? Akshay, Mansi,
No, sir, no.
Nida. Hello, Rufia.
Yes, sir.
Are you understand it or not?
Yes, sir.
Okay. Just I am repeating for you, especially because you have joined, okay, delay. Electric dipole in the sense, assembling of two charges, two equal and opposite charges, okay, and separation between them are very small. Then they constitute electric dipole. Okay. In this nature, electric dipole and monopoles are also available, just like electron, protons are monopole bodies, and the dipole is like HCl, hydrochloric acid, sodium chloride, and magnet. These are the dipole bodies. Okay. The condition of dipole is that the magnitude of the both charges, okay, always be same, as well as the nature of these both charges should be opposite. Okay. The one of them will be positive and the another will be negative. Are you clear? And the separation between them will be very small. Then this formation or this system is said to be the dipole system. Are you clear? And now the next point, all of you have noted it or not?
Yes, sir.
Okay. The next point is electric dipole moment. What is the electric dipole moment? Electric dipole moment is generally measured. It generally measures strength of dipole. What does it measure? It measures strength, or you can say capability of dipole. Okay. Strength of dipole. You should draw once again the same dipole like this. Separation between them is 2L. We have taken 2L, right? Yeah. Separation between them is 2L. And the charges on the both end is plus Q and minus Q. Okay. Then the strength can be measured by the help of the equation P vector is equal to Q into 2L. Okay. This is the equation of electric dipole moment, which is used for the measure strength of the dipole. Are you clear? And now you have know already the unit of charge is coulomb and the unit of length is meter. So we can write here the SI unit of this dipole is always be, dipole moment always be coulomb meter. it is a vector quantity. It is a vector quantity, and the direction of dipole always be from negative charge to the positive charge. Okay. In this diagram, if you want to draw the direction of the dipole, then it will be along the, then it will be from minus q to the plus q charge. It will be the direction of the dipole. Are you clear? Are you clear or not?
Yes, sir.
Yeah, note it down, please. Note it down, please. Can we move on? Akshay, Mansi, Nida,
Yes,
Rufia,
sir.
all of you
Yes.
have noted it or not?
Yes, sir.
Okay, good. Now we are taking a question to understand it. Our question is that two charges plus 2 microcoulomb and minus 2 microcoulomb are placed at 0, 0, 2 and 0, 0, minus 2 mm. Calculate dipole moment of the system. Calculate dipole moment of the system. Now, it is given that the position of the charges in the coordinates form. You can look here. Okay. The position of the first charge is 0, 0, 2 and the another charge is 0, 0, minus 2. Then, first of all, we are drawing a coordinate system. And this one is your, one second. This one is your minus, this one is your z-axis. Okay. This one is x-axis, y-axis and z-axis. Can anyone tell me what is the means of the 0, 0, 2? Sorry, 0, 0, 2 and 0, 0, minus 2. This is the value of x, this is the value of y, and this one is the value of z. I mean along z-axis. This is your along x-axis, along y-axis and along z-axis. This is your plus z-axis. Okay. This is the plus x and plus y. What will be the minus z-axis? I think the minus z-axis, if we draw the plus z-axis behind it, then it will be the minus of z-axis. Are you understand it or not? All of you are understanding or not?
Yes, sir.
Okay. Now, what is the position of this? This is your plus z. You can look at here. On the z axis, x is 0, y is 0, and value of z is 2. Then we can take this value at this position. We are taking this value at this position. This is your coordinate of 0, 0, 2. Okay. Now, where this coordinate lie? This coordinate lies on the minus z axis because the value of z is in the negative term. So, it will be at this position. It is 0, 0, minus of 2. Are you clear or not? All of you are clear or not?
Yes.
Now, all of these positions are always measured from the origin. I mean, this is the separation from the origin is of 2, and this is also 2. So, can anyone tell me what will be the total separation from one coordinate?
4.
I mean, coordinate A to the coordinate B. It will be
4
mm. Or it's clear or not? Now,
Yes.
let's try to solve it. The value of Q, which is given as 2 microcoulomb and minus 2 microcoulomb. So you can write here plus minus 2 as well, which is equal to the 2 into 10 raised to the power minus of 6 coulomb. The separation between these two charges, I mean the value of 2L is 4 mm, which is equal to 4 into 10 raised to the power minus of 3 meter. Then what will be the value of the dipole moment? It will be electric dipole moment. It will be P is equal to Q into 2L. The value of P is equal to, value of Q is 2 into 10 raised to the power minus 6 into value of 2L is 4 into 10 raised to the power minus of 3. Finally, you got 4 into 2. It will be 8 into 10 raised to the power minus 6 and 10 raised to the power minus 3 will be 10 raised to the power minus of 9, and the unit is coulomb meter. This is your final answer of the dipole moment. Okay. Are you clear or not?
Yes, sir.
Yeah. Note it down, please. Mansi, Nida, Rufia, this question is clear or not?
Yes, sir.
Okay.
Yes, sir.
Yeah, note it down, please. Note it down fast, please. It's noted or not?
Yes, sir.
Now, the next question. Next question is calculate dipole moment of the system. The system is given as like this. This is your charge of minus 2q, and this one is the charge of plus q. This is your charge of plus q. The separation between all of the two charges is L, because we are considering here this is an equilateral triangle. Okay. Now, how can we calculate the dipole moment? To understand it, first of all, we are going to divide this charge in two different parts. Minus of 2q can be divided in two different parts, minus q and minus q. Are you clear? What is the reason to separate here? The reason is that the condition of the dipole moment is that charges should be, the first condition is same magnitude. Are you clear or not? Same magnitude. And the second condition is that opposite nature. Are you clear? This is the condition of the electric dipole. If we divide this minus 2q charge in the two half parts, okay, then we get minus of q and minus of q. By doing this, we can assemble this minus q with this plus q and we get a dipole. Similarly, this minus q charge with this plus q charge and we get the another dipole. All of you are understanding or not?
Yes, sir.
Yeah. Suppose that if you are not dividing this minus 2q charge, then what will happen? In this case, this 2q charge, if you want to assemble with this plus q charge, then the magnitude will be different. Okay? Because this is 2q and this one is the 1q, causing which the condition of dipole is not satisfied. Are you clear? Are you clear or not? Hello?
Yes, sir. Clear.
Mansi, Nida, Rufia, all of you are understanding or not?
Yes, sir.
Yeah, what is the reason? I am telling to all of you that what is the reason to to divide this charge? Okay. And now we have divided this minus 2q charge. Then what will be the direction of the dipole for the plus q charge? It will be along this direction. And for the another plus q charge, it will be along this direction. Okay. You can take it like P1 and this is your dipole of P2. And now you can see here at the same point, there are two vector quantities. P1 and P2 are acting in the, at some particular angle, and this angle is 60. How can we say it is 60? Because the triangle is equilateral triangle. So we should draw a resultant. The resultant will be in this direction. To calculate the resultant, we have an equation. I hope all of you are remember from the vector concept. The resultant is a square d square 2ab cos theta under root. Do you remember this equation from from
Yes,
class
sir.
11 or not?
Yes, sir.
Okay, so we are going to use this equation again here. Now in this we have already know the value of P1 is Q into L, and just one second, the value of P1 and P2 both are Q into L, so we can consider it as P. Now what will be the net dipole moment? The net value will be P1 square P2 square plus 2P1 P2 cos theta. We can write here P1 and P2 as P. It is P square 2P into P cos theta. This cos theta is actually cos 60 degree here. You can also write theta is 60 degree. Okay. Now 2P square cos 60. What is the value of cos 60? Cos 60 is 1 over
1 by
2. 2 is cancelled with 2 and you got 2P square plus P square root of, which is equal to the root of 3P square. Okay. Finally, you got P net is equal to P square. Okay. When you take the value, okay, when you take P outside from the root, then you get only P root of 3. What is the value of P? The value of P is Q into L. It will be QL root 3, which is your P net. Note it down, please. This is your final answer. Okay. This is your final answer. Note it down, please.
So P equal to Q to L, right?
Yeah. Because both are same magnitude, na? So we are taking here P1 and P2 both are same. We are considering both
Yes,
are
sir. But the
equal to
formula
the
is
P.
P equal to Q to L, right?
No. You can take L or 2L. Okay. What is the reason of the 2L? Just I am telling you that let's try to understand. This is your charge. The separation between the charges are always measured from the center of the dipole. Are you clear?
Okay, teacher. Yes,
And
sir.
when you
Yes, sir.
measure at the center of dipole, in this case, if you are taking like L, then this half part will be L by 2 and the another half part will be L by 2. Are you clear? And when you
Yes, sir.
go through the solving, are you clear? When you try to solve any question in this case, then you got a fractional value which is typical to solve. Okay. So just for easy calculation, we are considering here 2L. Then after dividing it, you get L and this is also L.
Okay, sir.
Are you understand it or not?
Yes, sir.
Yeah. So you can take L, 2L, A, 2A or any other values. Okay. According to your convenience of the calculations, right? Note it down, please. Done or not?
Done, sir.
Okay. Next question. This is very easy question, and I hope all of you can do it yourself. Calculate dipole moment of the system. The system is given as like this. This is your given system. The separation from this point O is A, and this is also A. This is your plus Q charge, and this one is the minus Q charge. Okay. And now calculate the dipole moment, please. All of you can solve it or not?
Yes, sir.
Try to do, please.
Done, sir.
All right. What is your answer?
Root 2 QA.
Okay, good. Mansi, Nida, Rufia, all of you have solved or not? Let's see here. What is the separation between these two charges? First of all, you should join these two charges with each other. This is just 1 second. This is the separation between these two charges. According to the Pythagoras theorem, if this side is A and this side is also A, then this side will be A root 2. And now the dipole moment P is equal to Q into L, or 2L you can say. This is Q A root 2. Finally, you got Q A root 2. This is your answer. Note it down, please. All of you have noted it? Now, the next heading is dipole field. What is the dipole field? Okay. Dipole field. Dipole field in the sense electric field of dipole. Electric field of dipole. Okay. To calculate the electric field of dipole, okay, we required some basic information, which is, suppose that you are taking a dipole like this. This is your dipole. Okay. These are your dipoles. This is your charge 1 and this is your another charge 2. You can take it like positive and negative charges. This is your charge plus Q and this one is the charge minus Q. Remember that if you draw a line along the line joining of these two charges, then it will be like this. Am I right or not? This is the line along the line joining of these two charges. This line is said to be the axial line. Remember that. This line is known as axial line, or sometimes it is also known as axis of dipole. Are you clear? Are you clear or not? And if you are taking any point on this line at anywhere, either in this region it may be, or in this region. Okay, there is no matter where you are taking, but the condition is that you are taking on the axial line. Then that point is said to be the axial point. Okay. All of you are understanding or not? The point laying on the axis or along the axis of the dipole is said to be the axial point. Okay. Similarly, if you are taking the another point on the another point here, then if you join this point from the axis of the dipole, then it always be perpendicular. Remember that. It always be perpendicular. Okay. This is your perpendicular line from the axis of the dipole. And this line is said to be the equatorial line. What is the name of this line? Equatorial line. Okay. You can also draw this along this direction. And this point is said to be equatorial point. Okay. Now, the third main point is that if you want to calculate the electric field due to a dipole at any other point instead of the axial and equatorial line, suppose that you are taking at this point, you want to calculate the electric field due to this dipole at this point. Okay. Then when you join this point from the origin, it will be like this. The angle between them is theta. Okay. This point is this point is neither be on the axial line nor on the equatorial line. Then this point is said to be the general point. Okay. This point is at the general point. You can take this general point at this position also or any other position. The condition is that it never lie on the axial line or equatorial line. This is said to be the general point and this is said to be the general line. Okay. Now we are going to calculate electric field of the dipole on axial line. This is our first heading. And after this, we will study the electric field of a dipole on equatorial line. Okay. And then we will calculate the electric field due to dipole at general point. Are you clear or not? These are three main headings which we are going to calculate. Or are you clear? Which we are going to calculate. Are you clear? All of you are clear or not? Hello?
Yes, sir.
Mansi, Nida, Rufia, all of you are understanding or not?
Yes, sir.
Okay, good. Now, please note it down. All of the information, please. Note it down, please. Can we move on?
Yes, sir.
Okay, good. Next heading. Next heading is electric field due to dipole on axial line. Electric field due to dipole on axial line. We are going to understand it. Okay. Consider a point P . Consider a point P at separation R from center of dipole. We are taking a dipole like this. This is our dipole. This is a minus Q charge and this one is the plus Q charge. We are taking the another point on its axis. This point is P. This is the center of the dipole O, and the separation between this dipole is 2A. Okay. Then what will be the distance of the dipole? What will be the distance of the dipole from plus Q charge? From plus Q charge, sorry. The separation between these two charges are taken as 2A, and the separation between point P and center O is considered as R. Are you clear? Now, then what will be the separation? What will be the separation from minus Q charge to the point P? It will be R plus A. Are you understand it or not? If the total separation is A, then it is your A, and this also be A. Okay. Now the total distance between the minus Q charge and the point P will be R plus A. And the separation between plus Q charge and point P will be, you can take it here. This will be R minus A. All of you are understanding this point or not? This total diagram. Are you clear?
So can you repeat again?
Sorry? All of you are clear or not from this diagram?
Sir, can you repeat?
Okay. Let's see again. First of all, we have taken as a dipole. Okay. We are going to take a dipole first. This is your dipole. If this is your dipole, then this is your charge of minus Q, and this is the charge of plus Q. And the separation between them is, what is the separation between them? The separation between them is 2A. Are you understand it till here? Are you clear or not? Hello? All of you are clear or not till here? We have taken 2A separation between these two charges. Okay. And the center of the dipole is this. Then can we tell that the separation from center of dipole to the minus Q and the center of dipole to the plus Q, both are A? Can we say or not? Then it will be 2A total distance. Are you clear? Akshay.
Yes, sir, clear, sir.
Akshay, Rufia,
Yes, sir.
Mansi, all
Sir,
of you are
clear,
clear
hello?
till here?
Yes, sir.
Okay. Then we are going to calculate electric field due to this dipole at point P. And this point P is laying on the axial line of the dipole. This is your axial line. This is your axial line. And this one is the point P. Now, can you tell me, we have already know, remember that we have already know all of the separations for the dipole always be measured from the center of the dipole. Now, can anyone tell me what is the separation from plus Q charge to the point P? 1 second, 1 second. Now, we are taking one another thing, which is distance from center of the dipole, because all of the distances are measured from the center. So the distance from center of dipole to the point P is R. Okay. These are the basic information which we have, okay, which we are taking here. Now, what is the separation between plus Q charge and point P? Anyone can tell me, please? What is the separation from plus Q charge to the point P?
R minus A.
R minus
A.
A. Because this is the separation of A. And if we subtract A from R, then we get this separation, R minus A. You are right, Akshay. And other one like Mansi, Nida, all of you are understanding till here?
Yes,
Hello?
sir.
All of you understanding till here? And now, can anyone tell me what will be the separation of minus q charge to the point P? Nida, can you tell me please? What will be the separation of minus q charge to the point P? Hello?
Yes.
Yeah. What will be the separation? Tell me please.
Minus Q to P
Minus q to the point P. What will be the separation?
plus
R plus
A.
A. Good. Because the separation from this is R and the another separation is A. When we add them R plus A, then we get the separation between minus q to plus q. All of you are clear or not? All of you are
Yes,
clear
sir.
or not
Yes.
till now? Hello?
Yes, sir.
Yeah, okay, good. Now, we are taking this diagram. We are going to calculate it now. What is the value of E? E in the sense electric field at point P due to plus Q charge. All of you are remember about the electric field equation? The equation of electric field is KQ over R square. Do you remember it or not from the
Yes,
last
yes.
lecture? All of
Yes,
you
sir.
remember? Okay. Then what will be the electric field at P due to the charge plus Q? It will be E plus, in the sense electric field due to the positive charge. Okay. Is equal to K Q over R minus A. What is the separation from point P to the plus Q charge? This is R minus A. So we are taking here R minus A square. Okay. Into unit vector of, unit vector of P. Similarly, electric field at P due to minus Q charge, it will be E of minus Q is equal to KQ. What is R? R is your R plus A. So we can take it R plus A square into unit vector of P, which is, into unit vector of P. Now, another next point is that what will be the direction of electric field due to the plus Q charge at point P? What will be the direction due to plus Q charge?
I cap.
It will be away from plus Q. Am I right? It will be away because positive charge always generates electric field and electric fields always go away from the positive charge. So this is the direction of the electric field due to the positive charge. Similarly, this is the direction of the electric field due to the negative charge. Okay. So this unit vector will be in positive and the unit vector of P due to the negative charge, you can look at here, it is laying in the minus x, okay, in the minus x direction. So we can consider here minus P. Are you clear or not?
Yes, sir.
Okay. Now, net electric field at P. What will be the net electric field at P? I think it will be E net will be E of plus Q charge plus E of minus Q charge. I mean, we are going to add both equations. You can take it like equation 1 and equation 2. Okay. Then what is the value of E plus Q? What is the value of E plus Q? E plus Q. This one. K Q over R minus A square plus the value of E minus Q is this. K Q over, one second, yeah, R plus A square into unit vector of minus P. And the unit vector of this is plus P. Okay. Finally, you got, if you take the common as like, sorry, if you try to multiply this minus sign into the equation, you got KQ over R minus A square unit vector of P plus KQ over R plus A square. One second. When you multiply this minus sign with this, then you got here minus sign. Okay. And this is your now plus P. Finally, if you take the common as K into Q and unit vector of P, then you get in the bracket 1 over R minus A square minus 1 over R plus A square. All of you are understanding till this point or not?
Yes, sir.
Okay. All of you, Aisha, Rufia, Mansi, Nida, all of you are clear till here?
Yes, sir.
Okay. Good. Please note it down. Please note it down till here, then we will continue it. This is the half part solution till now.
Done, sir.
All of you have done? Hello? All of you have completed till here?
Yes, sir.
Please do fast.
Sir, done.
Okay, good. Aisha. Sorry. Rufia. Rufia, you are understanding or not?
Yes, sir.
Okay, good. Now, once again, I am going to write this equation on the next page. To continue it, our value is K Q unit vector of P 1 over R minus A square minus 1 over R plus A square. Okay. Then you can take at LCM. After taking LCM, you get R minus A square, R plus A square. Then after taking LCM and solving it, you get R plus A square minus R minus A square. Now try to expand the values, bracket values. You get R square, A square, 2AR minus R square, A square minus 2AR over R minus A square. Sorry, this R minus A square and R plus A square will be R square minus A square whole square. Okay. Then it will be KQP. When you multiply this minus sign into this bracket, okay, then we get R square, A square 2AR minus R square minus A square plus 2AR over R square minus A square whole square. R square A square will cancel R square A square. Now we get KQ P vector in bracket 2AR and 2AR will be 4AR. 4AR over R square minus A square whole square. Okay. Please note it down till here. Note it down fast. All of you have noted it? Hello?
Yes, sir.
Okay. Now, I hope you have remembered that the equation of dipole P is equal to Q into 2A. Do you remember or not? This is the equation of electric dipole moment. Okay. Now, we are going to arrange this value first. All right. We are taken as K here. Okay. K we have taken here. Q into 2A. We have completed Q, A and 2 here. Okay. And again we are writing here 2 into R unit vector of P over R square minus A square whole square. This point is clear or not? This point is clear or not?
Yes, sir.
Okay. Then we get Q into 2A. Q into 2A is P. K P into unit vector of P into 2R over R square minus A square whole square. And now, from class 11th of unit vector, you have already know the unit vector is equal to the vector over mod of vector. Okay. Or you can also say this is the magnitude of vector also. Then we can write here vector of P is equal to unit vector of P into P. You can look at here this value is this. This is same or not?
Yes,
Okay.
sir.
So at the place of P into P unit vector of P, we can write vector of P. We are going to replace it again. K vector P 2R over R square minus A square whole square. Are you clear? Are you clear or not?
Yes, sir.
This is the general equation of E. Okay. Note it down these 3 steps and also write these reference values. Okay. Note it down. Then we will move on. Noted or not?
Yes, sir.
Okay. We get the value of E is K vector of P 2R over R square minus A square whole square. Okay. Now, once again, we are going to remind, condition of dipole. What is the condition of dipole? Both charges should be equal magnitude. Okay. Second condition is both charges should be opposite in nature. And the third point is both charges are separated at very small separation. Are you clear? Now, look at this third point. What is it saying? Separation is very small. So we are going to take ideal condition here. Ideal dipole approximation is, in ideal dipole approximation, the separation between these two charges is this, and the separation between dipole and point P is R. Remember that this value of 2A is very, very small as compared to the R. Are you clear? This is your approximation. Okay. This is the approximation. All of you are clear?
Yes, sir.
Yes.
Now, for ideal dipole approximation, we are taking A is very, very less than R. So, R square minus A square can be approximated as R square only, because we can neglect A. Okay. Why? What is the reason of neglecting here? Because it is very, very small. Then what will be this equation? Then E is equal to 2K P vector into R over R square whole square, which is equal to 2K P vector into R over R to the power 4. You can cancel one R to the power of this R. And finally, we get E is equal to 2K vector P over R cube. 1 second. You can take it right like 1 second. R and R to the power 4. Mention one more step here. R over R cube into R. R is cancelled with R. You get R to the power 3. Okay, just for understanding, okay, I have increased one more step here. So please note it down. This is your final equation. Note it down, please. And also we can write here, your E is inversely proportional to the R to the power 3. Okay. Are you clear? Any issues?
No, sir.
Nida,
No, sir.
Aisha, Mansi,
No, sir.
all of you have any issues or not? It is clear or not? Is it is clear?
Yes.
Note it down, please. Hello. Hello.
Yes, sir.
All of you have noted it or not?
Yes, sir. Done.
Okay, good. Now the next point, we are going to calculate once again direction. How can we see or how can we calculate the direction? Or how can we draw the direction? Okay. Just for understanding, the direction of electric field is always the same. Okay. Is same as that of vector P. Now we are taking two different cases here. This is your dipole. This is your dipole. This one is of minus Q. And this is your plus of Q. And what will be the direction at this point P? This is our first case. In another case, we have reversed this dipole. If we have reversed this dipole, then this is your plus Q and this is your minus Q. And now what will be the direction of this dipole at this point P? Okay. Remember that from the previous slide, we have already studied that the direction of the dipole is, you can remember here, where is dipole? You can look at here, what will be the direction? The direction is from minus Q to the plus Q charge. Are you clear or not? Do you remember? All of you remember or not this point? Then, what will be the direction in first case? In the first case, it will be from minus to the plus Q charge. I mean, the direction will be along this line. Okay. So we can write here the field. This is your direction of the dipole. Remember that. If this is the direction of dipole, then we can say the direction of electric field also be in the same direction of the dipole. Are you clear or not? This is your direction of field. And if the direction of dipole in the second case is from minus Q to the plus Q, then you can look, it is just opposite to the case one. Then electric field, direction of electric field also will be in the same direction as the electric dipole. It will be also in this direction. All of you are clear or not?
Yes, sir.
Okay. So we can say the direction of electric field, is same as that of P. Okay. Note it down, please. Note it down, please.
Done, sir.
Note it down, all of you, please. Fast. The next point, the next heading is electric field on equatorial line electric field on equatorial line of dipole. This is our next heading. Note it down and we will discuss it in our next class. Okay? Because it is also a big calculation. So it is not possible in this lecture today. Okay? Hello?
Okay, sir.
Akshay, is there
Yes,
any
yes.
issue in this class? Sorry,
No,
in this
sir.
lecture?
No, no.
Akshay, Aisa, Mansi, Nida, all of you have any issues?
No, sir.
No? All right. Then we are going to our class today and we